So in the last lecture, we have learned simple Java programs, right? This simple program where we put a statement Java is better than C++. Class sample. This is how we write the main method inside the class. Public static void main. Argument string args. System.out.println. To print a simple statement, you need to use the class name, the object name, and then the method name. This is the simple program. We have seen each and every statement in detail. We have learned one more program where we have used two classes in the same Java program. As you can see, the name of such Java program will be same as that of the class name, which contains the main method. So here, room area.java program, which calculates the area of a room by having one class which will declare those two variables and initialize their value. And the class with main method will create the object from that class and then calculate the area by applying formula. We have studied the concept of how do we create instance of an object using new in Java where the heap memory is located. Okay, so your object is actually getting stored inside the heap memory locations in Java, because in Java we don't use pointers. Okay, so whenever you are using new, it is actually uh, allocating the memory inside heap to that particular class object, and then it is returning the address of that memory location. So it is actually kind of a reference. Okay, so we are not basically using here the concept of pointers, but the concept of reference to that object created. Okay, how the heap memory, it is just a random free floating memory. It is not a particular format like the stack where we stored in order. The first come goes last, then the second element at the top. Push pop operations and then LIFO pattern is used to extract the elements from stack. It is not like that. So heap is just random memory or free floating memory. Okay, where which is used in Java to store the object variables and the program code. Then we have learned in details Java program structure, the documentation section. Okay, here you can see the sequence whenever you want to write Java program. This should be the approach, okay, of the programmer to write down the program. Okay, so this sequence you can follow. The documentation section, it contains the comment lines where you will explain about the program, what it is about, why you are writing it. Okay, so that the reader will find it easier to understand the meaning of your code. Package statements. Package is a collection of classes. So here you have to mention that particular package name which you are going to use in your program. Import statements. Here you have to name that particular class from this package that you are going to use in your program. Interface statements. If you are using multiple inheritance in your program, then you need to mention the interface statements here. And then comes the class definitions. Your Java program can contain multiple number of classes. That depends on the complexity of your Java program. So you can have hundreds of classes in single Java program, and all those classes should be defined before you are defining the main method class. Inside the main method class, which is the essential part of any Java program, you have to create the objects from those classes. Here you will actually establish communication among those objects, means calling methods from these classes, and then one by one statement of this main method will execute. And when we will reach at the closing brace, okay, whenever it will be encountered, the control goes back to the operating system. Okay. Till then it just be there in the program. So main method is the one where your actual execution started. Starts. Here it is given in detail what every section contains. Documentation section, package statement. This is how we include the package student. This is just an example. There are many built-in packages available in Java library. You want to import class test from the package student, then you have to write it like this in the import statement, import student.test, separated by the dot or period, and then semicolon. Interface statement, class definition, main method class. Then we started tokens. As you can see, it's here the elements of the Java program. So Java program is basically collection of classes. Classes are collection of methods. Method is collection of expression and statements, and each expression is made up of token. So individual unit of the program is known as a token. As you can see here, the declaration statement combination of token, expression or statements combination of token, and methods are combination of ultimately the combination of tokens. So five types of tokens: reserved keywords, identifiers, literals, operators, separators in Java. Okay, five types of tokens. 50 reserved keywords in Java. These are them. All are lowercase letters. रिजर्व कीवर्ड्स मतलब ये प्रोग्राम स्पेसिफिक कीवर्ड्स होते हैं और इनका कुछ स्पेसिफिक मीनिंग होता है, ठीक है, एंड वी कांट यूज देम एज अवर ओन क्लास नेम और अवर ओन वेरिएबल नेम. आप अपने प्रोग्राम में उनको किसी भी यूजर डिफाइंड आइडेंटिफायर के लिए यूज नहीं कर सकते ये नाम, ठीक है. सो इंस्टेड ऑफ दीज नेम्स यू कैन गिव एनी नेम. आइडेंटिफायर्स मतलब प्रोग्रामर ने दिए हुए नेम्स टू द वेरिएबल, टू द मेथड, टू द क्लासेस, टू द पैकेजेस, टू द इंटरफेसेस. There are certain rules to be followed while naming the identifiers. Remember, Java is a case sensitive language. You must be careful while naming the identifiers. Uppercase and lowercase letters are treated as distinct in Java. Some more naming convention for classes. You have to start the name of class with uppercase letter and then subsequent in the letters as an uppercase. The remaining letters as small case and then subsequent next word to be written in uppercase. If you are giving name to the methods and variables, then start with the lowercase. If you are giving names to the constants, then write down it in a complete uppercase letters, all uppercase letters. If there are more than one words, then you have to separate them using the underscore. Literals means the sequence of characters which are representing constant values, okay, in the program code. So they are as it is stored inside the memory location. If suppose this is your memory, then here at some address xyz, you will be storing the literal value. Okay, so this is as it is stored, maybe a sequence of characters, sequence of digit. So depending on that, there are five types of literals: integer literal, character literals, string literal, boolean literal, and floating point literals. We already discussed these topics in last lecture. Okay. Operators, we are going to learn in detail in the as the last topic of this unit. Okay, so operator you are already familiar with, which is a symbol which will take one or more argument, will operate on them, okay, on those operands and will produce some result. So we are going to learn many more operators: arithmetic, boolean, logical, comparison, increment, decrement in the next chapter. Separators which are used to indicate the group of code, like parentheses, brackets, curly brackets, square brackets, semicolon, comma, period. Okay. Their respective use, what are they used for, is given here. Then constants in Java. two types of constants, numeric and character. Numeric constants means again subdivided into the integer constants or real constants. Integer means the whole numbers and real constants are the fractional values. Character constant means enclosed in the single quotes treated as character constants. Enclosed in the double quotes treated as the string constants. Am I audible?
Yes, ma'am.
Then again, there are some different types of the integer constants: decimal, octal, hexadecimal integers. And decimal integers, as you can see here, the number system I have shown you here. It consists of 0 to 9, combination of 0 to 9 digits. Okay. In octal, you can use the combination of 0 to 7. In hexadecimal, you use the combination of 0 to 9 and then followed by A, B, C, D, E, F, which are representing respectively 10, 11, 12, 13, 14, 15, and 10, 11, 12, 13, 14, and 15. So in total 16. Okay. We have already discussed these examples, how to identify the decimal integer constant, octal integer constant preceded by 0. Hexadecimal integer constants are preceded by 0x or 0 small x, 0 capital X. Okay. Real constants, fractional part values. They are represented using this notation mantissa e exponent. So what is the use of this? That as you can see, the larger numbers will take up more memory to store. So we can use the mantissa exponential notation to store such numbers or represent such numbers. So what it will do, it will take less space, because you can simply see here as an example 215.65 can be simply written as 2.1565 e2. So here e2 means 10 to the power 2. Okay, so exponential 2 means 10 to the power 2. So multiply this number with 100, that is 10 to the power 2, you will get this number. Okay, so as you can see here in front of e, you can give any power 50, 60. So instead of writing the complete number of 50 digit, you can simply write it into 5 to 6 digit. So that is the advantage of using mantissa e exponent notation. Single character constants, string constants. Then the next topic, okay, we will be learning is variables. Okay, यहाँ तक जो अभी डिस्कस किया वो लास्ट लेक्चर में हो चुका था. Now we will today start from the variables. Okay, so what is variable? So variable मतलब memory locations. Okay, means whenever you are writing some वेरिएबल डिक्लेरेशन, सपोज हियर यू कैन सी इन टोटल, ये आप लोगों ने बहुत बार किया होगा. आप लोग एक वेरिएबल लिखते हैं लेकिन एक्चुअली बैकएंड में क्या होता है, तो ये जो सो दिस टोटल इज एक्चुअली a name of certain memory location. Okay, so this total is actually a name of certain memory location. Suppose ये कोई मेमोरी लोकेशन है A B C D. Okay, A B C D. So this A B C D memory location, यहाँ पे आपका एक्चुअल कंटेंट रहता है, राइट, ये आपकी मेमोरी है. तो यहाँ पे एक्चुअल डेटा रहेगा, यहाँ पे एक्चुअल डेटा रहेगा, ठीक है, यहाँ यहाँ यहाँ, और यहाँ पे एड्रेसेस रहेंगे. तो ये जो एड्रेस है ये हम ध्यान में नहीं रख सकते हैं, तो हम इसलिए वेरिएबल बनाते हैं. तो वेरिएबल मतलब इस आइडेंटिफायर को एक दिया हुआ उसका मेमोरी लोकेशन होता है. तो जैसे आप टोटल लिखते हैं तो टोटल एक आइडेंटिफायर हो गया जो उस एड्रेस के लिए एबीसीडी के लिए दूसरा नाम है. ठीक है, तो क्योंकि हम वो हेक्साडेसिमल एड्रेस सिस्टम याद नहीं रख सकते हैं, इसलिए हम उसे इसी से रेफर करते हैं. तो जब भी आप टोटल बोलोगे इट गोज टू एक्चुअली दिस एड्रेस. जब आप इसमें कोई वैल्यू देते हो जैसे इन टोटल इज इक्वल टू 0, सो इट इज गेटिंग स्टोर्ड लाइक दिस. तो यहाँ आपकी मेमोरी में यहाँ इस कंटेंट जहाँ पे स्टोर होता है एक्चुअल, तो यहाँ 0 वैल्यू असाइन हो जाएंगी इस लोकेशन पे. ओके, सो variables are nothing but the memory locations that are associated with the identifiers. Understood? And see, they are variable means vary, can vary, like constant can't change during the execution of the program. but variables may take different values at different times. So that's why their name is variables. Okay, and before using any variable, you must declare it. Okay, in the program, you have to declare it. What is the syntax of declaration? You have already done these things in the C program, C++ program. You just have to write down the data type and then variable name. Data type will decide how it will be stored inside the memory and how much byte it will take. Okay, so its size and type should be mentioned before writing the variable name. Okay, as you can see the examples in total. Okay, total is a variable of type integer. Then long. Okay, int takes how many bytes? Int take 2 bytes, right, to store inside the memory. So total, wherever it will be stored, it will be taking 2 bytes to store itself. Then long takes how many? 8 bytes. Okay, then double. Okay, double takes 4. So you can assign the values to the variables also in the same line when you are declaring it, like in total is equals to 0. आप वहीं पे assign कर सकते हो, या फिर अगर आपने एक बार declare कर दिया तो next line में आपको लिखना पड़ेगा total is equals to 0. So instead of writing the two different statements, what we can do, we can assign them the values in the same line. In total is equals to 0. Okay, these rules are very much similar to the C, C++. Okay, you'll find it similar, but still I'm discussing it. Okay, so that you will find the similarities how we write programs in Java, and there were similarity between C and C++ programming also. Int count is equals to 20, comma sum is equals to 50. So if you want to declare the and initialize the variable of same data type, you can just separate them with the comma. Then variables fall into two different types. One of primitive and second is reference. Primitive types means the built-in types. Okay. So just like these are the 8 primitive data types available in Java, which we are going to study in detail. Okay, in the further slides. So for now, just remember that variable can be of primitive types: byte, short, int, long, float, double, char, boolean. And then reference types, second type. Variables can be of reference type or class types, means we can call them as a user defined types, क्योंकि class हम लोग लिखते हैं. So whenever we are creating the variables of class like objects of the class, then it is actually called as a reference type variable. So what happens in Java, see, whenever you are creating an object, okay, so like this string s, so you are creating just an object. But when you are assigning it, see, string s is equals to new string hello there. So what you are doing, actually you are creating an instance of this object of this class type. Okay, so whenever we are writing s is equals to a new string of hello there, so hello there, ये जो नया इंस्टेंस क्रिएट हुआ है स्ट्रिंग टाइप क्लास का, so s is actually the reference to this object. Okay, s variable is actually the reference to this object. So reference होना मतलब कि इसका address store करना. So wherever it is stored, its address will be referred by s. Okay, so if you are assigning the object to a variable, the variable is actually assigned a reference. Assigned a reference मतलब इसका address यहाँ पे hold होता है. Like if you are writing wall b, okay, so you are creating just an object. But if you are writing wall b is equals to new of wall, okay, so you are actually creating instance. Okay, so somewhere there the object's address will be referred now by b. Okay, so this is something new in Java which was not there in C. Though you have studied the concept of reference variable, similar concept we can apply it to refer to the object here. Okay, not the variable stored, but the obviously class is an object is a class variable. So for the class object, we are going to use this concept of reference. ओके, सो रेफरेंस यानी आप लोग ध्यान में रखो कि जब भी हम यहाँ पे बॉल पी लिख रहे हैं तो सिंपली एक ऑब्जेक्ट क्रिएट हो रहा है, लेकिन आप जब बॉल पी इज इक्वल टू न्यू बॉल लिख रहे हैं, सो एक्चुअली रेफरेंस इज गेटिंग क्रिएटेड, मतलब ये जो नया एक ऑब्जेक्ट आपका बन रहा है, इसका क्या हो रहा है, यहाँ पे एड्रेस स्टोर हो रहा है बी में। तो जब भी आप बी को रेफर करते हो तो एक्चुअली वो एड्रेस से उस ऑब्जेक्ट को रेफर कर रहा है। डायरेक्टली ऑब्जेक्ट स्टोर नहीं होता है उसमें, लेकिन एड्रेस स्टोर होता है उसका। उसे पता होता है कि ऑब्जेक्ट कहाँ है, वो खुद ऑब्जेक्ट को कंटेन नहीं करता है, बट उसे पता है कि ऑब्जेक्ट कहाँ है, एंड हेंस वी परफॉर्म द ऑपरेशंस थ्रू दैट on the object. Then, since we have completed what are variables, now let us see what are the different data types in Java. मतलब जिस टाइप के क्या हो सकते हैं, डिफरेंट डिफरेंट वेरिएबल्स हम यूज कर सकते हैं, वो कौन से डेटा टाइप्स है जावा में। सो एवरी वेरिएबल इन जावा हैज अ डेटा टाइप, एंड डेटा टाइप्स क्या स्पेसिफाई करते हैं, साइज और टाइप, मतलब कैसे स्टोर होगा वो पर्टिकुलर वेरिएबल मेमोरी में, कितने बाइट्स लेगा, वो सब चीजें उस वेरिएबल के डेटा टाइप से पता चलती है। कि जैसे ही हम स्टेटमेंट लिखते हैं इन टोटल, तो इससे हमें पता चलता है कि टोटल इंटीजर टाइप का वेरिएबल है, और दूसरी चीज कि इसे 2 बाइट स्टोर करने के लिए लगेंगे मेमोरी में। तो डेटा टाइप जो हमें जावा में पढ़ने हैं, दे आर बेसिकली ऑफ टू टाइप्स, प्रिमिटिव एंड नॉन प्रिमिटिव। ठीक है, उसमें से भी आपको जो सिलेबस में मेनली डेटा टाइप्स पढ़ने हैं वो है प्रिमिटिव, मींस बिल्ट इन। ओके, एंड नॉन प्रिमिटिव वी कैन कॉल देम एज द यूजर डिफाइंड, लाइक क्लास, इंटरफेस, अरेज, बट यू नीड नॉट हैव टू स्टडी देम। Okay, what you have to study is mainly primitive data types. Okay, now primitive data types are divided into numeric and non-numeric, two categories. Numeric में integer, floating point. Integer में again there are 4 different types: byte, short, int, long. And floating में you can see float and double. Non-numeric data types, char and boolean, these two subcategories are available. Okay, so the thing we are going to focus on is the 8 primitive data types in Java. Okay, so primitive data types, they are predefined, built in, okay, by the language, and they'll be using these reserved keywords. See, primitive data types, numeric, non-numeric. Numeric में integer, floating point. Non-numeric में character and boolean. अब हम ये सारे डेटा टाइप्स जो है वो डिटेल में पढ़ेंगे, ठीक है। न्यूमेरिक में हम देखेंगे इंटीजर, उसके बाद फ्लोटिंग पॉइंट, और नॉन न्यूमेरिक में हम देखेंगे कैरेक्टर और बूलियन। तो इंटीजर्स, आई होप यू आर टेकिंग डाउन द नोट्स, एटलीस्ट ड्रॉ द टेबल्स। Okay, so integers are used to represent the whole numbers. Okay, and they are again divided into the 4 subtypes, only depending on their size they used to sorry, so there is only a difference of the size in which they are stored. Okay, all of them belong to the category of integers. The sub categories are byte, short, int, and long. Now here you can see their size in bits is given and their size in bytes is given, and this is the value range. Now let me clear you the what is the bits and bytes. See here, 8 bits. Okay, the numbers are stored in the obviously in the 0 1 format, okay, of the binary. So 8 bits, see, I have made here the diagram how they are stored: 1 2 3 4 5 6 7 8. 8 bits together constitute 1 byte. Okay, 8 bits means how many bytes? 1 byte. Okay, so similarly 2 byte means how many bits? Multiply with 8. Okay, so 16 bit. If I'm writing 3 byte, then how many bits? 24 bits, right? So just remember that 8 bits is equals to 1 byte. Okay, 8 bit is equals to 1 byte. Bits are byte. So that's why I have specified here two separate columns. Okay, in bits I have also mentioned the size, and in bytes also I have mentioned here the size. So byte data type of integer. So byte integer numbers will take up 1 byte to store inside memory. Short integer data type variable will take up 2 bytes to store in memory. Int type integer will take up 4 bytes to store in memory. And long type integer will take up 8 bytes to store in memory. Are you getting my point? Okay. Then this is the range. This is the minimum value and this is the maximum value. Means these are the range means with this data type numbers or this kind of numbers, up to what range you can represent the numbers that is given here. So from minus 127 to plus 20. These numbers can be represented with such data type. Then here also minimum range and maximum range. Minimum range for int, maximum range for long also there is kind of large number which consists of 18 decimal digits. So I have not written here that number. But remember for long also there is a 18 decimal digit minimum range and maximum. Then Java does not support unsigned data types. So every value or integer numbers in Java will be either positive or negative. So there will be a sign in front of for every integer number in Java. And what we can do here, if we can, if as we know that if the larger is the number, it will take more memory to store. Okay, and what we can do if there is a smaller number which can fit in the lesser size data type, then use it wherever possible. To store the smaller number, prefer to use the less sized data type. What it will do, it will take less time to manipulate such numbers also, and hence your execution speed will increase. So it is preferable if you can store the 50. Okay, suppose there is a number 50, which can be stored in int also, it can be stored in the short also, it can be stored in byte also. Then prefer the byte data type to store the number 50 because it will take up only 1 byte and manipulation will be easier. Okay, so keep in mind while writing the programs. Then second data type floating. At least draw this table, students. Then there are two floating types, floating point types. Depend and they're differentiated based on the size they used to store. So float type values they are used to store the single precision numbers, and double type they are used to store the double precision numbers. The difference between single precision and double precision is just that how many bytes they or bits they used to store the mantissa and exponent part. Okay, only that is the difference. So float type numbers they take up 32 bits. Okay, and double type floating numbers they take up 64 bits to store. So can you tell me how many bytes? 32 means how many bytes? Divided by 8, so 4 bytes. Similarly, double, how many bytes? 8 bytes. Okay.
8 bytes.
Okay. Here you can see the minimum range, okay, which is expressed in the exponential notation form, okay, and maximum value for float type, for double type, minimum and maximum. So in between this range, you can represent the number with the float, and this range from this to this, you can represent the number using double floating point type. And there is one more thing. In the floating data types, it supports a special value called as a not a number. So these type of values they are used when there is a kind of situation. Suppose you are dividing some particular number with zero. Okay, so the answer may be infinity. To stop such looping, we may represent such numbers or as an answer. We can just print these numbers. Okay, in that case, which is a special value, not a number, which helps to stop the infinite looping, or some situation in the program where your system, or you may come out of the program, or system may crash. So represent such critical values, we may use this special type. Okay. Then the third data type, which comes under the category of non-numeric. Okay. Numeric में integer floating, non-numeric में character and boolean. So characters value, they are basically using in Java Unicode character set. In C, C++, you have used the ASCII character coding. ASCII कोडिंग मतलब कैरेक्टर को स्टोर करने का ही एक तरीका है, ठीक है। इसके अलावा और भी mechanisms available है, how do we store the character or represent the character। तो दूसरी जो एक कैरेक्टर सिस्टम एनकोडिंग सिस्टम है वो है यूनिकोड, एक है ASCII और एक है यूनिकोड, ठीक है। तो जावा में यूनिकोड कैरेक्टर एनकोडिंग स्कीम यूज होती है। तो ASCII में क्या है कि एक बाइट यूज होता है एक कैरेक्टर स्टोर करने के लिए। ओके, सो एक बाइट में 7 बिट्स आर यूज्ड, sorry, 8 bits are used to store the single character. Okay, so 1 char, 1 byte in ASCII encoding scheme. But what is the case with Unicode? We use 2 byte to store a single character. So per character, for 1 char, how many bytes are used? 2 bytes. So actually 16 bits. And obviously characters वही है, small ABC, capital ABC, 0, 1, special characters, okay, everything. But which encoding scheme is used? Unicode. Okay. So remember, it will take up 2 bytes to store the single character. And then Boolean. When do we use the Boolean data type? When we need to set a particular condition and we want the result as true or false, whether this condition was true or false, at that time we use the Boolean data type. Okay, so these two words, true and false, ये reserved keywords है, ठीक है, Boolean type के इसमें यूज होते हैं। इसको हम Boolean data types को जो लिखते हैं तो Boolean BOOLEAN यही कीवर्ड यूज होता है, and it uses only 1 bit. So true means it is 1 and false means 0. Okay, so it takes up only 1 bit. तो जैसे फ्लैग की वैल्यू चेक करनी है, या फिर इफ यू वांट टू कंपैरिजन ऑपरेटर्स है, जैसे वेदर द नंबर इज ग्रेटर देन है, इक्वल है कि नहीं है, तो ये जो कंपैरिजन ऑपरेटर्स है उनमें जनरली यूज होते हैं बूलियन टाइप वैल्यूज। ओके, then since we have studied the various data types, now we can move towards the typecasting. So typecasting is, you can see the definition, process of converting one data type to another data type is known as typecasting. See the syntax. The variable 2, which is of some different type, you want to convert it to the type of variable 1, you just have to mention here in bracket, okay, the type you want to convert it to. See here, int m is equals to 50. Okay, so m is a variable of type integer. I know int takes up how many? 2 bytes. Okay, now 2 bytes के instead of using 2 bytes हम क्या कर सकते हैं, ये जो 50 नंबर है मुझे पता है ये 1 बाइट में भी स्टोर हो सकता है, तो हम इसे कास्टिंग कर देंगे, ठीक है। इससे हमारी क्या होगी, लेस मेमोरी स्पेस यूज होगी। तो अगर आपको 50 नंबर को बाइट टाइप में कन्वर्ट करना है, क्योंकि बेसिकली आपने डिफाइन करते टाइम इंट में किया है, तो आप इसको कन्वर्ट कर सकते हैं बाइट में, और यही कन्वर्शन को हम टाइप कास्टिंग बोलते हैं। अगर आपको कास्टिंग करना है तो आप क्या लिखना पड़ता है, आप नया वेरिएबल लो, बाइट टाइप का एन वेरिएबल इज इक्वल्स टू, आपको किसे कन्वर्ट करना है, तो एम को कन्वर्ट करना है, तो आप यहाँ पे लिखिए बाइट ऑफ एम। तो यहाँ क्या होगा, जो 50 नंबर है इट विल बी गेटिंग कन्वर्टेड इनटू द बाइट एंड विल बी असाइन्ड टू द न्यू वेरिएबल एन, which is of type byte. Okay, so this is known as a casting. Or you can convert the n variable again into the long ओके अगर आपको इस छोटे नंबर को ही जो लेस साइज ले रहा है टू स्टोर, अगर आपको इसको लार्जर स्पेस देनी है टू गेट स्टोर्ड, देन व्हाट यू कैन डू, you can again convert it into the long data type. So this is how you can convert a variable from one data type to another data type. ठीक है, टाइप कास्टिंग के दो टाइप्स है, ऑटोमेटिक कन्वर्शन और एक्सप्लिसिट। एक्सप्लिसिट मतलब मैनुअल। इम्प्लिसिट कास्टिंग, एक्सप्लिसिट कास्टिंग। इम्प्लिसिट कास्टिंग जब आपका सोर्स वैल्यू जो है वो ऑलरेडी लेसर साइज डेटा टाइप से लार्जर डेटा टाइप में कन्वर्ट हो रहा है, तो वो ऑटोमेटिकली हो जाता है। जैसे इस एग्जांपल में आप देख सकते हो डबल डी इज इक्वल्स टू 3 लिखा है, तो यहाँ डबल डी इज इक्वल्स टू 3 के सामने डबल डी इज इक्वल्स टू डबल ऑफ 3 लिखने की कोई जरूरत नहीं है। डी एक इंटीजर टाइप का नंबर है, ठीक है, और डबल आपको पता है ये फ्लोट में आता है, मतलब फ्रैक्शनल वैल्यूज रिप्रेजेंट करते हैं। तो आप जैसे ही लेसर डेटा टाइप वैल्यू को लार्जर डेटा टाइप वैल्यू में कन्वर्ट कर रहे हो, तो वहां इम्प्लिसिट कास्टिंग अप्लाई हो जाता है, मतलब ऑटोमेटिक कन्वर्शन डन बाय द जावा लैंग्वेज। ओके, सो और जावा कंपाइलर। So as you can see, you need not have to write this much thing. You can simply write double d is equals to 3. तो यहाँ हम बोलते हैं टाइप वाइडनिंग हो रहा है, तो जब सोर्स वैल्यू लेस डेटा टाइप साइज की है, लेस साइज की है, और जिसमें आपको कन्वर्ट करना है मतलब डेस्टिनेशन लार्जर साइज का है, उस केस में इम्प्लिसिट कास्टिंग परफॉर्म होता है। एक्सप्लिसिट कास्टिंग कहाँ होता है, जहां आप टाइप नैरोइंग कर रहे हो, मतलब अगर आप बड़े डेटा टाइप में से छोटे इसमें कन्वर्ट कर रहे हो, तो वहां एक्सप्लिसिट कास्टिंग परफॉर्म करना पड़ता है। ऐसे केस में आपको यहाँ पे मेंशन करना पड़ेगा, ठीक है, जो आपका सिंटैक्स है वो प्रॉपर पूरा लिखना पड़ेगा। जैसे कि इस केस में हमने यहाँ डबल डी इक्वल टू डायरेक्टली 3 लिखा, यहाँ सामने डबल इनसाइड ब्रैकेट 3 ऐसा नहीं लिखा, क्योंकि ये ऑटोमेटिक कन्वर्शन हो जाता है, इसीलिए इसे ऑटोमेटिक बोलते हैं ना, कुछ लिखने की जरूरत नहीं पड़ी सिंटैक्स एंड ऑल। एक्सप्लिसिट में आपको मेंशन करना पड़ेगा कि यू आर कन्वर्टिंग दिस फ्लोटिंग पॉइंट, ओके दिस इज अ फ्लोटिंग पॉइंट नंबर, I can see that. Okay, it is a fractional value, so it is floating point number, and you are converting it into the lesser size data type. तो जब आपकी सोर्स वैल्यू लार्जर है और आप उसको स्मॉलर साइज में, डेस्टिनेशन स्मॉलर है, उस केस में आपको एक्सप्लिसिट कास्टिंग परफॉर्म करना पड़ता है। ओके, एज यू कैन सी यहाँ पे क्या हो जाएगा, फ्रैक्शनल पार्ट ट्रंकेट हो जाएगा एंड फाइनल वैल्यू विच विल बी स्टोर्ड इनटू आई विल बी 3। ओके, दिस इज हाउ द फ्लोटिंग पॉइंट नंबर्स कन्वर्टेड इनटू इंट। ये कुछ कन्वर्शन रूल्स है कास्टिंग के। Java automatically converts the operand based on the following rules. Let me complete this topic and we will finish the lecture. Okay. And if one of the operand is double, the other is converted into double. If one of the operand is float, other is converted into float. If one of the operand is long, the other is converted into long. And if both operands means other than these cases, both operands are converted into int. So this is the automatic conversion supported. And casting that results in no loss of data during the conversion. This table you can see from 2. So from byte, if you are converting into short, char, int, long, float, double, then there is no loss of data, because wherever we are converting the larger data type values into the smaller, there may be a loss of data, क्योंकि आपके larger number में suppose 32 bits लग रहे हैं, आप उसको 8 bit में store करने की कोशिश कर रहे हो, तो obviously आपके 24 bits का loss हो सकता है उस केस में। तो ऐसी कास्टिंग जिसमें कोई loss of data नहीं होगा, वो ये है टेबल में जो है। ओके, और मैं कुछ इंस्ट्रक्शन यूनिट टेस्ट रिगार्डिंग, मुझे कुछ स्टूडेंट्स पूछ रहे हैं कि सिलेबस नहीं है, तो सिलेबस ऑलरेडी आप नोट सेक्शन में जाओ, यहाँ पे आपके नोट सेक्शन में सिलेबस प्रोवाइडेड है, ठीक है। ये यहाँ पे आप देख सकते हैं सिलेबस, ठीक है। उसके बाद आपके वेरी फर्स्ट प्रेजेंटेशन में इंट्रोडक्शन टू ओओपी, इसमें भी सिलेबस कवर्ड है, मैंने एक्सप्लेन किया था। उसके बाद यहाँ पे चैनल की लिंक है जिसमें सारे वीडियोस अपलोड हो रहे हैं। यहाँ पे आप देखो पहले C++ का पीडीएफ, आपके जो 4 यूनिट है फर्स्ट 4 वो इस बुक में है पीडीएफ में, और लास्ट 2 यूनिट इस बुक में है, ठीक है। तो ये जावा की भी अपलोड की है और C++ की भी बुक अपलोड की है यहाँ पे, so you can refer from that, ठीक है। Some students are asking me give the syllabus, so this is the syllabus PDF already shared. You can just scroll down. Everything is given here. Okay.
Yes, ma'am.
Okay. Two units will be there for the unit test, third and fourth unit. Okay. Operator overloading and inheritance. Study well. You may leave the meet. और किसी को कुछ डाउट होगा सेशनल से रिगार्डिंग यू कैन आस्क मी